This is my little HF SSTC setup. That's just what I've been calling it, but it's just a high frequency circuit made by Tesla Unmer. And this is the one I actually had a lot of trouble with. Started off using this cap, was popping FETs like crazy, and I came to the conclusion changing the variable capacitor out was my solution. But I went back and remembered that this particular one had these auxiliary caps, I guess you could call them. So you see they've got these little smaller ones on the side of each bank. The actual range I needed for this cap was only up to like 100 picofarad. So by paralleling up 3 of those, I was able to get what I needed, and worked pretty good that way. I haven't had problems with it since, and I was able to get rid of that huge bulky capacitor. And one of the things I forgot to try with this was modulating the input with an audio signal by using one of these PWM circuits I've been using as interrupters. The plan is to plug in a little Bluetooth module I've got in this audio jack here, and I'm going to try that first, and the output voltage of that little module is not going to be very high, so without extra amplifying, just wanted to see how loud that would be. But just to show, and I'm going to be using this, I've been using this supply, which by the way, this supply is made to run off drill batteries, so that's a pretty beefy cell right there. That's why this is able to run off batteries. And got it, see, I put it at about 16 volts or so, and where if I turn it up high enough, I shouldn't really hear the oscillation. I sort of hear a little bit. So it's at 100% duty now, and I'm going to draw the arc out. So it kind of struggles at 100%, all the way to 100%. I've got a different breakout point on there now, so it wants to jump around and burn the little foil tip at times, but anyway, that's how it's going, and you can hear how loud it is, varying the frequency. That is extremely loud. And it kind of went out there. So I'd have to feed it a good amount of power to keep it going steady, which, you know, obviously, I mean, that'd be the plan anyway. But it's got pretty good volume. This PWM might not be the best particular circuit. I just grabbed a random one, but doing this sweep right here more or less kind of tells me what the audio would sound like as far as volume. And that's pretty damn loud. So I've got it playing random music right now. It kind of works. Oh, I need to cut the dip cycle. So this is just some random YouTube thing. See, the volume is very low. I can barely hear it. So the signal coming from this little guy, it's just not really doing it. As you can see, it's running from the PWM at maybe something like 20 kilohertz. Cut it up and down. And this voltage is not accurate. So you see, it cut it off. It's at about 18. Let's put it at about 24. A lot of interference. See, when I move my hand over to the PWM, got a lot of interference. So it has the potential to work, but I would imagine I need to boost the signal a lot. And I've tried it from my computer, but it introduced a lot of noise in the speakers, so I need to boost the signal another way. But technically, you can see that's might be all it takes to have a simple setup like that where you just use the PWM. Of course, this is pushing a lot of watts right there, so probably need a bigger heatsink, but the concept more or less works. Of the same circuit, the simple HF SSTC. It's got that little ball on it, so of course a super sharp, man, that thing's magnetic as hell right now. A super sharp breakout point is what's necessary. So you can see it does break out a little bit. This is only a 2 megahertz breakout, so it's that low doesn't really resemble a flame, you know. Just for the, you know, it's just cool. I like this circuit, just is so cool for the, you know, like a little coil of this size. Sit there and pull some pretty good hot arcs. Little screw on there and there. Whew. So here goes this circuit on this coil. It's another coil. I was going to use this on the other circuit, but it actually rings at only 4 megahertz. But it still works alright on this circuit. It's about the same deal. Cut that up and pull stupid hot arcs. Pulls it up to about 3 amps tops. Doing that. That's about 90 watts. Put this little coil back on here, or on this circuit, to see what it do. I'll cut that up. It's pulling about an amp and 3/4. You see it's got the little breakout there. Still get the hot arc that you can pull off little thing. But if you back the pot down, it gets a little more intense at a certain point. But if you back it down too far, they'll go out like that. So you have to bring it up just enough. So where I have it up here, it wants to give the best, you know, breakout, but it's also singeing the crap out of this coil because it's just trying to arc and melting. So you need to have a little looser coupling there. With this setup, I had rigged a damn light bulb to have the breakout point arc to the bottom of the bulb, and I was pulling arcs off the, you know, outside of the glass, and it only took like a couple seconds for the glass to pop and break through. So, you know, with these type of deals, it's like, you know, insulator my ass, but glass definitely don't really stand a chance. But I feel like these little guys, so stuff like that is what this would be good for, because, you know, I'm cranking a ton of watts to get that powerful arc to be able to annihilate that glass. But this guy is much higher frequency. You know, the plasma is so hot, it just gets it done. So now I've taken this little coil that I had before and actually halved it, and actually wasn't hard to do because where the primary was before in the last setup, it had basically melted the little plastic former, and I was able to break it apart real easily. It's sort of detuning itself here and there by getting too hot. But you can see when I draw it out, I get the cool little high frequency flame. Sort of hard to see that, but I like the way that looks. far as coming from a real tiny coil. And again, you know, pull the hot arcs off of it. Painstakingly wound this coil earlier. I had to insulate the crap out of it, so it looks a little bigger than it is, but very hair thin gauge wire. It's about probably 40 gauge I put on there. So that's about the coil right there. About right there. No, that's probably about like that. So it's about 25 millimeters, this particular coil, and it's on the same Tesla Unmeer circuit, and same deal. It's about 31 volts, pulls very low power, but A, I get a pretty good field from it, and B, I can pull out a plasma flame like that. And that's not a bad little plasma flame for the size of that coil right there. See, right now I'm pulling an amp, so that is about 30 watts to be able to do that. If I cut the voltage down, we're about 24 volts now. It's still just barely burning. Alright, so I put this little screw on there. Cut it back on. Put this little screw on there and try to draw out another arc. You can see, for one, that's a nice little arc. Whoops, that you can pull off a tiny little coil like that. Seems like it's so hot now it doesn't want to break out. Cut it off for a little bit. Well, cut it off, cut it back on. Oh, then it broke out automatically. I can kind of hear through my powered computer speakers when I have them turned on the intensity of high frequency oscillations. So again, that's a pretty wicked little arc pulling off this tiny freaking coil. That's also some pretty wicked little plasma from such a small coil. Obviously it starts to come out a lot more when I get closer to it like that. Doesn't really want to do much to other random bulbs I have, but man, that puts out a field. It's a badass little flame. Yeah, this is turning into one of my favorite circuits too right here. So simple. Yeah, look at that little guy. Tell you what though, these coils are probably getting very hot.